Hello, 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 and welcome to Hot Girl Math, or welcome back to my channel. This is my second video, so I doubt anyone's coming back to this. But anyways, today we are going to be looking at 3 quadratic equations in standard form, and we are going to convert them to vertex form. All right. Now, let's start by defining what vertex form even looks like. And, well, vertex form is f of x equals a times x minus h squared plus k. So this is the form that we're going to convert this equation to right here. And the reason being is because this form, the h value and the k value, is the point on a parabola. It's either the maximum value or the minimum value. It's the vertex of the point, depending on if the graph is opening upwards or downwards. So we want to find that point, all right, and use the vertex formula to do that. So let's go ahead and jump into it. All right, so the first thing that we're going to do here is we're going to label each term A, B, and C. All right, A, B, and C. Now, to find the value, you're going to look at the coefficient in front of each term. So for example, x squared, this term right here, there is a hidden 1 coefficient. So A would be equal to 1. For the second term, we see 6x. The 6 is the coefficient of the second term, and so we're going to label B as 6. And C, the constant term, is just 5. All right. Now, over on the right-hand side, I have a list of steps 1 through 5. We're going to walk through each of these together. So the first thing that I'm going to do is actually, for simplicity reasons, I'm going to change f of x just to y because they're the same thing, but I want to get rid of those parentheses just to make it a little less intimidating. So y equals x squared plus 6x plus 5. This is what we're starting with here. Now the first thing that we're going to do, number 1, is to move the constant. And we're going to move this over to the left-hand side where the y is. So that means I'm going to subtract 5 from both sides. All right, and we'll get y minus 5 equals x squared plus 6x. All right, amazing. Let's look at step number 2. Step number 2 says factor out the leading coefficient a. Well, if we look at our a term over here, we can see that the coefficient is 1. The coefficient is 1 right here. And if we factor out a 1, it's not really going to change our equation at all. So it really doesn't make any sense to do that. So we're actually just going to skip this step for this problem specifically. All right, so we're going to move on to number 3, where we are going to complete the square for the b term, so b divided by 2, and whatever answer we get for that, we're going to square it. So our b term is, again, this 6x, which we established over on the left-hand side. All right, but we're just going to take that coefficient, which is 6, and we're going to divide it by 2, which will give us 3, and then we're going to square that term, which will give us 9. All right, so from here, after we're done getting that 9 value, we are going to add 9 to both the left-hand side and the right-hand side. All right, so y minus 5 plus 9 equals x squared plus 6x plus 9. All right, so the reason why we added it to both sides is to make sure the equation was balanced. If I just added it to the right-hand side of the equation, then it wouldn't be balanced with the left-hand side of the equation. We would completely change everything. So we want to keep it the same. And so from here we're going to simplify. Negative 5, or y minus 5 plus 9. Negative 5 plus 9 is 4. So y plus 4 equals x squared plus 6x plus 9. Now, if we really look at this, you might notice something here. This is if my pen will work for me, this is a perfect, she's pretty thick, perfect square trinomial. So what we can do is we can actually reduce this just to a binomial squared. And in order to do that, we're going to look at the middle term again. We're going to look at this 6 and shortcut. All you do is you take that b value or that middle term and you divide it by 2, or you take half of that value, and that's it. You have the x in front, positive 3, which is half of the middle term, and then you square it. And if you want to check, all you have to do is FOIL this back out. X plus 3 plus x plus 3, and you will get the same you'll get the perfect square trinomial up top. So with that being said, you have y plus 4 equals x plus 3 squared. And it looks really, really close to what we're trying to get up here. Oops. Oh no, it's being annoying. It looks really close to what we're trying to get up here with our vertex formula. The only thing is that we just need to get f of x, or this y value, by itself. So in order to do that, we just subtract 4. Y equals x plus 3 squared minus 4. And boom, that is our answer in vertex form. And then to find the vertex, all you do, you look at the h value and you look at the k value. You always take the opposite of what the h value is. So if it's a positive, you'll take the negative. If it's a negative, you'll take the positive. So for here we have positive 3. The answer is going to be negative 3, negative 4. Boom, shakalaka, we did that. We did that. Next, equation. Let's just keep going. We're on a roll. We've got 2 more left to get through, and I believe in us. So this next equation, f of x equals 3x squared plus 12x plus 5. First things first again, we are going to define a, b, and c. Our a value, oops, I keep doing that thing. I need it to be a equals the leading coefficient in front of this x squared term, which is 3. Wow, this is turning into a disaster, but we're going to keep going. Just keep going. B, or b value, is the second term, and the coefficient in front of that x is 12. And our c is just the constant. C for constant, is 5. All right, so we have all those written out. Now, again, I'm going to, for simplicity, take f of x and make it y. And then everything else stays the same. So 3x squared plus 12x plus 5. Okay, now what do we do first? Well, if we look over on the right, again, we have to move the constant. So that c value, that 5, the precious 5. I love constants, by the way. They're my favorite because they're just like so familiar, right? So we are going to move that over to the left-hand side by subtracting it from both sides. All right. So we end up with y minus 5 equals 3x squared plus 12x. Amazing. So this time we can actually do number 2 because we have a leading coefficient in front of the a term. And the a term is this 3, or yes, the a term is this 3x squared. I mean the term, the coefficient, goodness, I'm having trouble speaking. The coefficient is 3. So we're going to factor that out. And what that's going to look like. We're going to keep the left-hand side the same. Y minus 5 equals 3. What's important to note here, you're not taking out the greatest common factor. You're not taking out 3x. You're just taking out the 3. It took me a while to get used to that as well, but it's just something you're going to have to memorize. So 3x squared. And because we're taking out the 3, this 12 is actually going to come to 4x. All right? So we have y minus 5 equals 3x squared plus 4x. All right, we're getting close. So step 3, we need to now complete the square. So we need to take that b term, which kind of seems hidden at this point, but it's this 4. It was originally the 12, but since we factored out the 3, it is now the 4. All right, and you know what? Now that I think about it, now it might be a little confusing because now you're going to have to go and change the b value here to 4 if you want to. I don't know. I just kind of like writing out a, b, and c. You don't have to do that necessarily, but I just realized that it could be confusing because now that when you factor it out, you don't want to reference the 12 for the completing the square part. You want to reference the 4 after you factor out the 3. So if you'd like to do it that way, be my guest. You can do it that way. Just be extra careful if you do. So moving forward, we have the b squared, which is 4. So 4 divided by 2 is 2, and we are going to square that value, so we'll get 4. All right, and just like before, we have to add this 4 to the left-hand side of the equation and also the right-hand side, but with one small caveat because of this. So I'm going to keep the left-hand side the same for now. And I'll do 3x squared plus 4x. And I'm going to add the 4 at the end and then close the parentheses. Now, what do we see here? We see that this 3 value is actually being distributed to this 4. So if we just added 4 on this side, it wouldn't be the same because actually on the right-hand side, it's 12. So in order to make the left-hand side and the right-hand side the same, on the left-hand side, we would want to add, instead of 4, we would want to add 12. Again, because that 3 is being distributed to the 4, 4 times 3 is 12. All right, are you with me? Sounds good. So, negative 5 plus 12 is 7. So we have y plus 7 equals 3x squared. Oh no, what happened to my x squared? Plus 4x plus 4. All right, and then again, for inside of this parentheses, we have a perfect square trinomial. So that means we can factor and turn it into a binomial by taking the middle term, this 4, oh no, this 4 right here, and taking half of that middle term. All right, so inside the parentheses, it becomes x plus 2 squared. And then everything else will stay the same for now. All right, so we're down to our last step, and that's to get y by itself, and we do that by subtracting negative 7 on both sides, and we end up with y equals 3 x plus 2 squared minus 7. And that is our vertex form. And the vertex is going to be this 2, but remember, since it's positive, we want to switch the sign, so it's going to be -2 and -7. Bow wow. All right. Let's move on to the last problem that I have for us today. Now this one, do not be afraid. Fractions are okay. Fractions are fun. I love a good challenge. You're going to encounter fractions, so you might as well get used to them. And this one's going to be very fun. So let's do this together. Everything is pretty similar. Let's go ahead. I'm not going to write out A, B, and C this time, but if you'd like to do that, go ahead. So I'm not going to do that for this one. We're just going to jump right into it by also recognizing that you can change this A value to X if you want to. A can be anything. It can be a circle, it can be a square, it can be an ice cream cone, it can be anything that you want it to be. So I'm just going to keep it the same, and I'm going to change f of A to y. And then I'll do -1/3 a squared plus 6a plus 1. I love how I wrote my a's differently. That's typical. I don't know why I do that a lot, and I don't even realize until after I do it. But anyways, okay. So step 1, move the constant. So we are subtracting this negative or -1 on both sides of the equation. And we'll get y minus 1 equals -1/3 a squared plus 6a. All right, step number 2. Factor out the leading coefficient a. Now, the leading coefficient in front of this a squared term is -1/3. So we're going to factor that out. So the left-hand side stays the same as y minus 1. And we're going to take out the -1/3. So parentheses a squared. Again, we're not taking out the greatest common factor, which would, if we were taking out the greatest common factor, it'd be -1/3 a. But we're not doing that. We're just taking out the leading coefficient. And then, well, in order to take out -1/3 from 6, we will have to do 6 divided by -1/3, which you can calculate by taking 6 and multiplying it by the reciprocal of -1/3, which is -3/1. And that, the 6 is over 1, and that will give us -18/1, which is just -18. All right, so we're going to put -18 in here and there. We fact out a -1/3 from 6. And do not forget the a, like I did. Make sure you got that a. And for some reason, I don't know why I interchange the way I write my a's. I don't know why. I noticed that I do that quite often when I'm solving problems. But anyways, not to get sidetracked. So, moving on. We finished number 2. Number 3, complete the square. B squared, or b divided by 2 squared, and that value squared. And it is a little confusing because we have an a here. This second term is still our b term. So let me just highlight this, make sure we understand that this 18, or this -18, I should say, is our b term. So we will take -18, we will divide that by 2, so that gives us -9. And when we square that, we get a positive 81. All right. So then when we write everything out, including this 81, we get y minus 1 equals negative 1/3 a squared minus 18a plus 81. Let's see here. So this negative 1/3 is, because it's being distributed, we're distributing that, and therefore we will get negative 1/3 times 81, which will get us negative 81 over 3, which reduces to a negative 27. So again, because we're distributing that negative 1/3, we can't just add 81 to the left-hand side and then add 81 to the right-hand side as well, because they're going to be uneven since that right-hand side is distributed. So we're actually going to have to add negative 27. So y minus 1 plus a negative 27 equals negative 1/3 a squared minus 18a plus 81. All right, so when we simplify this, a negative 1 plus a negative 27, we get y minus 28 equals, and just so we don't get ahead of ourselves, this right here, again, is a perfect square trinomial. So we can take this middle term of negative 18, and we'll take half of this. So a minus half of 18 is 9, and we're going to square it. If it was plus a squared plus 18, we would do a plus 9, but since it's negative 18, we're doing a minus 9 squared. All right? And therefore, I actually, oh my goodness, I forgot to bring over the negative 1/3. That is a very important piece of the puzzle. Again, a minus 9 squared. And the last step, get y by itself. So we just add 28 to both sides. And we are left with the final equation in vertex form, if this will ever drop down for me. Y equals negative 1/3 a minus 9 squared plus 28. Beautiful. And our vertex is this h value and this k value, h and k. And remember, it's the opposite. So since it's negative 9, our h value is actually going to be positive 9. And our k value is going to be positive 28. All right. And there we did it. We just solved 3 quadratic standard form equations and turned them into vertex form. And we also found the vertex. So that is today's video. I appreciate you joining me if you did join me, and I look forward to the next one. Thank you. Bye.